Hey you cool cats and kittens out there, how you doing? This is Carol Baskins from the Big Cat Animal Rescue. How is everybody's calculus day going? It's really not Carol Baskins. How y'all doing? This is Mr. Thompson, as you know. And we're back to improper integrals. I'm going to skip through the first chunk if you want to see their build-up on all this, and I think it's a good explanation. But since we've already talked about this in BC, I'm not going to belabor the issue. I just want to get to the examples here. So if you want, I've posted the answer keys. You can look at that. I just want to get to these last four problems here, just as a reminder. So if you need any help with these, refer to the answer keys. Both the work problems as well as the notes are all posted on Canvas right now. So you've got this. Just wanted to start with this one. An improper integral comes about two ways. One, and the easiest way to find this one is you've got an infinity or negative infinity as one of the limits of integration. Okay? We'll talk about the other case where it's improper. Improper not because it's rude, not because it curses, not because... No, it's improper because you have a number that you can't point to on the number line. You can't point to infinity. So instead, you would be expected to do this. Now, right above here, I'm going to write what I hope you were taught formally last year. And then I'm going to say, okay, but this year, and again, depending on where you go and what you're studying next year, your teacher may or may not worry about the formal way. But this is what I would expect you to write this. Limit as a approaches infinity of the integral from 0 to a of e to the negative x dx, and then you would continue. Okay, but you just continue on with the limit notation instead of having this one as infinity as a number. That's what's improper. Okay. One, it's hard for me to check your work now lately anyways, but two, I'm not going to belabor the point on why we're using limits. We're going to more practical, for example, my degree is engineering. I'm going to be more engineering, get the job done focus as opposed to pure and beautiful science and math and the loveliness of it all. So get it done. Let's just do some problems here. What's the antiderivative of e to the negative x? Well, you got negative e to the negative x from 0 to infinity. Okay? Plug in that limit there. You got negative e to the negative infinity minus negative e to the 0 power. All right? And again, you'd have limit as a approaches negative infinity, negative e to the a, that kind of thing. So you've got this. You could see that. Well, negative exponents sometimes confuse us. So I'm going to rewrite this as negative 1 over e to the infinity plus, well, what's e to the 0? That's just 1. However, what is negative 1 over e to some ginormous number? Isn't that going to be 0? So 0 plus 1 is 1. That limit converges, or that integral converges there. Okay? Ooh, this one looks like arctan. In fact, it is arctan. So arctan x from 0 to infinity. And this one, same idea. Arctan x from negative infinity to infinity. Again, I'm using the informal infinity as your limits as opposed to writing a limit as a approaches infinity formally. Okay? Well, this should tell me this is arctan infinity minus arctan 0. What angle has a positive infinity arctangent? That's pi over 2 minus what tangent, what angle has a tangent of 0? 0. So that first one is pi over 2. So the area under the curve of 1 over x squared from 0 to infinity converges to be pi over 2. Okay? This one would be arctan infinity minus arctan negative infinity. Okay? Well, arctan of infinity is what? Pi over 2? Minus what angle has a negative infinity? Negative pi over 2 And we could have done, in fact, we could have even done symmetry and just said 2 times that answer to get our answer, but we didn't. We got pi that way as well. All right. So again, the easiest ones to find for improper integrals is where you've got a limit. These have it right there. This one is actually improper too, and you might not see it right away, but why is it improper? Zero in the denominator. Okay, so again, if you were to see that, you would still use the limit as x, because it's going to be undefined, basically, right? I'm going to use zeros and ones, but you would want to check that. Okay, from 0 to 1, we have a denominator where it's 0, so that's an improper integral. So extra caution should be applied here. Sometimes they'll converge, sometimes they won't. Okay. The descriptions in the packet of the problems that I'm skipping out are all there, so you've seen that before. So what would that be? X to the negative 1/3, right? So x to the 2/3. Increase the power, divide by the power, so divide by 2/3 would be from 0 to 1. And we don't have a negative exponent anymore, so that's 3/2 times 1 to the 2/3, which is a nice easy one, minus 3/2 times 0. Well, 3/2 of this one does converge to 3/2. What about this one? This is the same as writing it integral x to the negative 3 dx from 0 to 1. And again, this is an improper integral because you got a 0 in the denominator possible. So if we increase that, x to the negative 2 divided by negative 2 from 0 to 1, or another way to write that would be negative 1 over 2x squared from 0 to 1, right? So we've got negative, that's 1/2, plugging in that one though, minus, what is this one going to be? Well, 1 over 0 is infinity, right? So does not exist. You could say that it diverges. Okay? So whenever you've got that infinity there, be careful. Actually, it'd probably be plus, but still. Minus the half there, right? So it diverges. Okay? Any questions? Any questions? Again, if you want to go through these to see all of the build-up for all that, great. Since this is review, I think you should be good. So nice, short and sweet. And I hope everybody's doing well. I bet you've seen there are new guidelines for grading. Grading is going to happen once a week, and it's all going to be the same type of grade. So I'm going to do daily grades, either a quiz or some kind of an assessment to see that you're still on board with us. So look for that. Low key. The grades have to be as high as what you earned last 9 weeks. So yeah, whatever. I'm not the one making these decisions, obviously, because I don't know what everybody else is dealing with. So this is certainly the most congenial way to keep everybody up to speed. My goal, as it always has been, is not to worry about your grade, but to worry about your learning. So I'm going to continue teaching ham, as the kids might say, and it's up to you to respond. If you just want to get the bare minimum done, what you reap is what you sow is kind of my motto. So those of us that aren't going to put a whole lot of work into it aren't going to get a whole lot out of it, and it is what it is, and it'll eventually catch up. But we want to get through this and get back on track, and that's what we're doing. So more than generous enough of a policy. I think everyone will be getting an A this 9 weeks. It is what it is. Take care. I will put up some practice problems as well, and if you have any questions, great. Thursday, look for a conference call time if you're listening to the video. Thursday, my students, you'll see that 8 to 8:30. I'll put that invite out, and you'll see that in case you've got any questions. and just check in too. Love to hear from you, because it's kind of lonely up here talking to a piece of paper, making jokes about the Netflix shows about strange people with big cats. Take care, and I hope everybody's well. Bye.